typically than an alcohol is, right? So alcohols generally we see that to deprotonate them irreversibly, we would need to use something like H- anions for the irreversible deprotonation of a thiol. Whereas, of an alcohol, sorry. Whereas with a thiol, we can irreversibly deprotonate a thiol with something like sodium hydroxide. So sodium hydroxide is a strong enough base to irreversibly deprotonate a thiol. Okay? And we'd, as Henry was saying, we'd rationalize that by the fact that sulfur is a much bigger, more polarizable atom than the oxygen is. Therefore better able to accommodate the negative charge in the anionic state. Therefore the thiol is more likely to lose its proton in the first place. Now this property is taken advantage of in the synthesis of thiols. So synthesis of alkyl thiols would often start from hydrogen sulfide, which is the stuff that you get in the smell of rotten eggs. So whereas the pKa of water is 15.7, the pKa of hydrogen sulfide, let's see now. What would you expect this pKa to be in relation to this?
It's going to be
This in comparison to this? Higher or lower pKa? Don't rush to answer, just think about it, then answer. Because then you're going to have to think about which anion is more stable, right? So if this gets deprotonated, which anion would be more stable? Now we should know already that it's going to be more stable than the hydroxide anion, right? But is that anion going to be more or less stable than this anion?
More stable.
going to be more stable because it's not no induction. There's no.
So if this is an alkyl group, we'd expect an electron donating effect that's absent here, right? So the pKa of hydrogen sulfide is only about 7. So you take advantage of that to use hydrogen sulfide to create this anion, probably by deprotonating with sodium hydroxide again. Create this anion, and then you could alkylate the anion by doing an SN2 type substitution with the sulfide. To make your thiol. Now, the interesting thing about thiols in a very general sense. It reminds us of that argument that we used in the first thing that we looked at when we came in here today, which is that because it's larger and more polarizable, thiols typically, and sulfides, the anions of thiols, tend to be better nucleophiles also than alkoxides or alcohols. So because they are larger and more polarizable, they're more willing to distort their electron densities to reach out for either a positive or partially positive carbon to make a new bond. Right? So typically thiols and sulfides are much better nucleophiles. So if we kind of compare, let's see, we're kind of doing a few different things at the same time. But if we compare if we remember here, this one was the stronger acid. Therefore, the sulfide anion is the weaker base. Since its conjugate acid is stronger. So therefore, the alkoxide is the stronger base. Relative to the sulfide, but the sulfide typically is the better nucleophile. This is going to be a more pronounced thing if you have a polar protic solvent, right? But think about it, any polar protic solvent that you have is going to be usually an alcohol or water, right? But in a more general sense, because of its greater polarizability, thiols and sulfides tend to be better nucleophiles than alkoxides or alcohols. Sarah, you're not liking that?
I'm just, so in a case where you would need like a smaller nucleophile in order to get into the, we were dealing with, it was hard to reach places where you want smaller nucleophiles with a better one. In this case, would the sulfur be able to distort its electron density more even though it's bigger?
Yeah, no, it distorts its electron density more because it's bigger, right? Because it's bigger and less electronegative, it distorts its electron density more easily, right? But in terms of size, that's not the kind of size thing that would be significant. So the size thing would be like a tertiary butoxide versus a methoxide, right? So that's the kind of size thing that would make a significant difference to how something acts as a nucleophile. So the idea is we could take, let's say, methylene thiol, treat it with sodium hydroxide,